And now, thanks to Doug, who stepped in at the last minute, I'm going to turn it over to Doug to talk about sharpening.
So I was invited to go down to Cumberland to the Quad State Bodgers to do a presentation on sharpening and stuff like that, talk about sharpening of tools. And as you can tell by tonight's beginning discussion, there's all sorts of different opinions about everything. So rather than actually trying to tell you how to sharpen your tools, I thought maybe I'd just give you a little bit of background about what it looks like and what sharp tools and everything look like. So this is a picture of 5 different sharpenings on different belts. I have here on this little fancy camera is a 1000x camera. It goes up to 1000x so that I can actually go in and start to look at edges. I can take a look at the up close and personal with all the edges I get if I want to. And the advantage of doing this is once you get into the focus, you can start to see variations in your grind. So if I go really long way off into really high magnification, I can start to see the very edge of the tool. And the purpose behind me showing you this is just to demonstrate. That's how I took these pictures that we're seeing here. I'm going to go back into my PowerPoint presentation now. What I did on this original presentation is to take a bunch of different grinds and show you the difference you get just from the grit of wheels and everything like that. And also with the different steels. So I have a cast steel. This is a Diston tool. This is a Greenlee tool with an 80 grit belt and a diamond hone. Then I have a 220 grit belt. This was and then a leather strop. And this last one here is a 220 grit belt, a diamond hone, and a leather strop.
But the marks you can see are all still residual from the grinding, correct?
Yes. But you can see that the 2 different steels ground very, very similar. The 80 grit with a diamond hone is not that different from the 220 grit with a diamond hone, because this cross section here is actually the diamond hone and not the 80 grit anymore. So as soon as you put a hone on there, you have to get through your original grind. And then the 220, the reason for showing you this 220 with a leather strop, what a leather strop does, it doesn't actually it polishes it, but if you look at this closely, it actually rounds the edge of it. So it doesn't actually sharpen it any further. All it does is make your edge shiny. So the real important part of doing this whole business is making sure, and another part is that you can see the roughness on this edge here as well. When you go from an 80 grit to a 220 grit to a 600 grit, you can get the same, you can get it really sharp, but it's the roughness on the edge that you're trying to get rid of, not the actual grit lines, because now you have 2 rough surfaces going together, so it's going to give you, so the finer it goes, the more precise it becomes. So right off the bat, the first question is, what grit do you use? Well, I don't really care what grit you use, because if you've got a 220 grit, you're going to get that surface. That's as sharp as it's going to get. It's not going to get any sharper than that. So it's going to have bumps on the surface. If it's a going to the diamond hone, you get a much sharper edge because it's a much finer grit. So truthfully, the finer the grit, the sharper the edge. How sharp do you need it? Again, everybody's got their own preference for sharpness. And you could say, if as long as I can cut myself with it, it's sharp enough. Yeah, John.
So just to be ridiculous, if you sharpen with a 350 or a 600,
yes,
as it dulls,
yes,
does it dull? It's not like, is it like sandpaper where people go, well, if you wear out your 80, it actually turns into 220 sandpaper. That's not the case.
No, it's not the case.
Is there any kind of analogy with
steel?
sharpness? If the 600 dulls more quickly, does it dull more quickly and become useless, or does it dull and become something more like a 350 or 220?
When tools actually dull, you start to get there's 2 ways of dulling. Either the outside surface, the corner surface I showed you, will literally make it rounder, or it will chip off. So obviously 220 or 600 going a little bit round may take it a little bit longer. but it's the strength of the edge that you're dealing with. And that's why people are talking about all these different types of steel for dullness, because inevitably what happens is as the steel, one of the terms used in steel is how well does it hold an edge? And that's a matter of the metallurgy behind it, high strength steel. But again, you can get lots of different strengths, and I have another presentation, I didn't go into that in detail on tonight, but you can get all sorts of different things. And are they designed? I actually, a lot of people say, well, high strength steel, if you really want to get a good steel for wood turning, you need a good a Shetland steel, right? Or something like that, a Sorby Shetland steel. I'm working at the moment with a steel manufacturing. I went to talk to their head of research, and he said, I said, well, I heard that Shetland steel is great steel. He said, that shit? Yeah, so it's like, and then I said, well, it's for wood turning. I said, oh, well, wood turning doesn't matter. So, pardon? Sheffield.
saying Shetland, I
meant Sheffield. I'm sorry.
Shetland's the pony.
Yeah, I know. Thanks, Barry, keeping me up. Sheffield. But again, he was talking about wood turning, and as soon as he said, well, wood turning, it was okay. Well, who cares? And so, and to be truthful, and this is another part of the presentation, wood turning predates the Iron Age. So in the Bronze Age, they were using bronze for making wood turning tools. So you can turn wood as long as it's sharp. It's just a matter of how sharp you want it, how long it stays sharp. So that's and so when it comes down to grits, then the real question, and this is tying to the question that's talking about before. So what?
Does someone have their hand raised?
Sorry, go ahead. Was that Dave?
I just want to make a comment about the stropping and the rounding the edges. A carving tool is a very V-shaped tool. It's not like a regular knife or anything like that. And when you're honing that, you're pressing down only on one side, so you're only doing one side at a time, but you're making sure that it's very flat on the surface. So if you're, quote, honing something like a skew, you're not going to hone it like a barbershop the old barbershop would strop a razor. You're going to hold it as flat as you can on a flat surface of maybe diamond white on your leather, and you're going to stroke it on both sides so it's very level, so you're not rounding the edge. You don't really strop a carving tool. You don't really strop a turning skew.
Thanks, Dave. He said it. What can I say? So going back to this whole business about, can you put us back on? Got it. Yeah, I got it here. So what are we doing when we're sharpening? We're actually just removing metal to create a new surface. And I'm saying it uses friction, which, because you're using friction, you're producing heat. And everybody talks about how hot can you make a tool, and I'll go into that in a few minutes. The difference between soft steels and hard steels is their ability to wear. And so it's a metallurgical compound and the heat treatment stuff. And all that the coarse wheel does is it removes the steel more quickly and easily. You can choose whatever grind you want, and it becomes down to optimization. How hot can you make your tool? This is a picture of the heat versus the color of steel. And if you get up into the red, people say, you got to be careful not to get it red. Well, in fact, this is the annealing temperature carbon steel, so it goes dead soft. And once you get dead soft, you can't do anything about it. You have to take it through an entire process again. You'll notice it doesn't say what the composition of the steel does. Those temperatures are for any steel you put up, So, people talk about blue. Those are aging temperatures. Once you get into those temperatures, does it soften the entire edge? No, it softens the area that gets that hot. It doesn't get, whatever. So if you're going into making different colors, you got to stay away from getting your tool too hot. That's simple. And I see a lot of people, when they're grinding their tools, they're pushing against it because they think it's going to grind faster. It doesn't grind faster when it's hot. All it does is make the steel soft and gum up your tool, gum up your grinding wheel, which is why people say about, what he's saying about you don't use coarse cubic boron nitride wheels for grinding steel. The reason is that when I saw one that had been destroyed, I looked at the surface of it, it was just covered with soft steel. And there's no way to get it off again, because it's actually a steel compound under that thing that's actually holding the cubic boron nitride in place. You can actually see that. I can show it to you if you're interested. Anybody want to see what the surface of steel?
No.
Pardon?
Show it to us.
Show it to
You know,
you?
Woodturner wonders, I don't know how effective it is, but they sell a liquid that is meant for, in the event that somebody has done carbon steel, heaven forbid aluminum, but has done carbon steel on a CBN wheel. And the guy who owns Woodturner Wonders claims it takes it out.
What grit is that wheel?
That's an 80 grit wheel there. And that's at about 1000X. If I go
What's the
down-
wheel next door to it?
220.
220?
So that's the 80 grit. That's a 220 at the same magnification. This was a 180. Again, same magnification. The bright spots are all your compounds, the compound that's holding the cubic boron nitride together. And you can see that the density is not uniform.
Yeah.
But, I mean, the problem with packing particles like that together is it just makes, they're very difficult to pack together. So, and if I take this over to any of the other wheels, you'll see a similar type of structure. So it doesn't really matter. And a vitrified wheel will show effectively the same type of structure. The basic difference between that and that. Obviously, you can see the huge difference in the grit size. But if I cover that up with steel, it doesn't matter what I've done, it won't grind. And unfortunately with these things, once they're covered with steel, I don't know of a way to get out of that. So back to your comment about making it, not using 80 grit, the problem is that you can generate, because it's a friction high, you can generate heat on these 80 grit wheels very, very quickly.
Oh, yeah.
So, you know, it's no time at all before it's gone blue on you. And then if you've gone to blue or red on that steel, on that wheel, chances are you ruined your wheel, that's all I can say.
Yeah.
So,
There's a blue wheel that you can use rough and steel,
Yeah.
steel on. But I wouldn't recommend doing any kind of roughing on each wheel because it's just loaded wheel.
yeah. And once you load it, it's done. That's all there is to it. So, but again, what do people think about it is what I want to do when I'm making grinding is I really want to push down hard on it. And it'll grind faster. No, it won't. It will heat up maybe because you're pushing in the friction, but it will not grind any faster and all that will happen. So my encouragement to anybody is when you're starting off, remember that let the wheel do the work, not you. And in fact, that's one of my things for anybody when they're wood turning. Let the tool do the work. If you're turning and you're not relaxed and you're doing whatever, it's a problem. Okay. So that is anybody have a tool they want to look at?
Anybody have?
Has that one a tool they want to look at?
What do they call that kind of camera?
This one's in a Max View, I think is what it's called.
Macro?
Max View, I think is what it's called. Max C, sorry.
Are they
Max
called
C.
like macro cameras, or what's the genre name, generic name?
Oh, it's just a macro camera. Sure.
Macro.
But this is actually quite high magnification because it can go up to 1000x. Normally, 1000x is your average microscope for anything, for macro stuff. See if I can see it. Show another one. There you go. This is a diamond hone. Oh, let's see what this.
That's the unused portion of a retractable utility knife.
Again, you can see how straight that edge is, And if I take it around to the end, I'm not sure if I can get it, but as you move it around, see those little reflection lines? Those little white spots?
You're getting off there.
Yeah, I know, I'm trying to, it's a problem with high magnification stuff on this thing here. That reflection spot is a flat spot, my grandfather always said. So if you can see your a light reflection, light only reflects off the surface. So if your edge is truly sharp, it won't reflect a piece of light. The other thing my grandfather we always said is about you may have heard on razor blade you get a wire edge. Well, a wire edge is just this tool getting the steel getting so soft, thin that it starts to flip back and forth. So anyway, one last tool for you. This is an 8,000 grit grinding stone. Again, if there's anything in here.
Washington stone.
It's Japanese, so I don't know. I think it's an artificial one. It's a very, very fine. So, I'm back on my. Let's go down to the next slide. Sorry, go ahead.
A comment on that color chart. That is not the color you will see your steel turn when you burn it. In the absence of light,
Yeah.
it's kind you buy
Yeah. Okay.
LED lights. They'll show some as being 2,700 degrees
Yeah.
and some as being 3,000. I don't know how high they get, but 2,700 is considered soft light. And on that chart, if you look at, I'm not sure if it goes as high as 2,700, but that's really the glowing of the steel, not, I burned it, I can see purple, I burned it.
No,
You burned it, but it's not what.
It's a reflection. Yeah, it's the radiation of the steel, radiant energy of the steel is causing that color.
Like in the old days with carbon steel, they'd say, well, to harden it, you heat it to dull cherry red.
Yeah, exactly. And that's what this is. Yeah. And in fact, that's, again, my metallurgy professor said that in the old days, the guys that knew how, the blacksmith could tell the temperature of a piece of steel within 10 degrees, for quenching, just by the color training. That's what took you 7 years to learn how to be a blacksmith. Not the hitting it with a hammer. That took like 10 minutes. But getting the color right. This was just a diagram to show steel phase diagram. And all I'm trying to show on that one is if you see the 3.4 in the middle, that temperature is at 1147 degrees Fahrenheit. That is where steel melts, cast iron melts. The one at 723 Celsius, which is about 1400 degrees Fahrenheit, that's where the reactions occur. It changes phase from one to another. So it's, again, that's just a composition effect. So I'm going to go down one more here. Next question. What's the right grind? What's the right angle for your grind? Well, I got this, my comment. When you're standing at the lathe, grab my tool. Imagine I got a piece of wood in here. I have to find the bevel of turn. It's most important in my mind to be comfortable in your stance, no more than anything else. And this angle here makes a heck of a difference to the angle you're holding your body as much as anything else. So finding the angle to me is, first of all, knowing the size, what you're turning against, and where the angle is turning. I have created for people who are interested the range of angles and swept-back angles that they recommend for skews. So this is the entire range of. I went into a sharpening website and they said that the included angle can be anywhere from 20 to 40 degrees, and straight to skewed and whatever skew angle, and they all work. They're all valid angles to use. So the important difference for you is what's comfortable for you. If I take this one, these two, that's a straight angle 30 degrees. This one is a skew angle with a grinder angle 50 degrees. Obviously, if I'm turning a piece, this is going to be, this blade is what you're using to cut with, and as you get it closer and closer to the, as you move it more closer and closer to vertical on the spindle, like that, it's obviously going to make a cleaner and cleaner cut. So if you want to get a really, really smooth, clean cut, you have to have it almost vertical on the spindle. But I'm holding that at a different angle. To get that angle is quite different than holding at this angle. You can see my elbow is way the heck out here. Mm-hmm. So the skew then becomes, the real issue about the skew is being able to hold it by your side, being able to be comfortable so that when you go into your dance and do all that sort of thing, you have the angle that gives you the best cut and smoothest cut all along. One of the advantages of having a Sorby, I got one. Barry sold me his, so I got this little thing here. Go back onto that one. They got this little thing that Sorby recommended angles for all the tools that you have on the bottom of it. A skew chisel has the recommended angle settings for the angle of the skew is 15 degrees and the main bevel and all that sort of stuff. And you can see they go anywhere from 15 to 90 degrees, and everybody has their own idea for shear scrapers. So why use a different angle? As I showed you before, we have the options of skew. You can either change the skew angle, the included angle, or the swept back shape. So now I'm going to go into this picture here. This is a picture of a flat skew versus a round skew wheel, and you see the red line here showing this is what would a flat grind is versus the shape of the grind on the 8-inch diameter wheel, or 8-inch diameter wheel. If I take a tangent, even though that says that that's a 30 degree or 15 degrees per side, the actual angle on this one that's done on the actual round grinding wheel is 9.5 degrees. What does that mean? That means that if I'm taking my tool like this, I'm coming down, I'm supposed to find the bevel and then find the edge. As soon as I've found that edge, I'm already 5 degrees angle going into the wood. Guess what that's going to do?
Something you don't want.
He's catching on quite quickly. So my point is that is one of the reasons that for a skew to stay away from this rounded edge or from the round side, and that's why I would recommend and again I'm going to go back in here. I've got another thing here. As I move this back and forth, you can see that the dotted blue line on the bottom and the black line, which is the curve, become closer and closer. So as I change my total included angle, get it higher and higher, I come straighter and straighter. So guess what, guys? The ones with the higher included angle, even when you grind it on these round grinding wheels, is going to be far less catchy for what you want. But the problem is it may not get as smooth or as sharp a cut as you'd like.
Hey, Doug.
Yeah.
How much of a degree does a difference does a degree make? I'm kind of saying bullshit on that. You know what's some of us turn with 60s, some turn with 45s, 50s. We all still manage to turn it. So what's the big deal with getting another degree or two on your grind? Sorry,
Jim. Jim, you're jumping the gun here because that's my comment too. Okay.
I'm sorry.
But my point, Jim, my point isn't that. My point is that there is a difference between, see this 38 here? There's a big difference between 38 as a total included angle and 70 included angle, and that big difference is down at the front there.
Now we're back.
The difference is this line here. That's the only difference I can see, other than the fact that, you know, obviously it's not necessarily a sharpened angle.
How much of an angle difference is that? That difference there, Doug? Just enlighten me, that's all. Oh, you're saying it's 37 to 76?
No, I'm saying it's 36 on that angle and 38, so it's 2 degrees.
Damn,
And now,
2 degrees don't make shit. I'm sorry.
and I'm not disagreeing with you, Jim.
Okay.
You don't apologize, but I'm saying back here, where it's a long skew and a long edge, 5 degrees does make a difference, because 5 degrees going into your wood will cause it to catch. Yeah.
So there's also another facet. I grind on a round CBN like this, but then I have a diamond thing that I put honing fluid on, and then I put my skew on there. So then you're changing that tip ever so infinitesimally on the very edge of the cut.
You've gone from a round grind to a flat grind doing that.
But only for like a
Doesn't matter
64th of an inch.
how much of the nose actually cuts the wood.
Exactly. So my question is, in your opinion, how does that factor into that?
Well, that's one of the reasons I'm bringing it up. Is that if you want to get rid of this effect,
Right.
And you have only a ground factor, then you have to start using a honing
Right, okay.
a stone to hone it on
Yeah.
to make it flat, and that will stop your catching effects. If I go into a similar thing on a scraper, this is just showing. If I have a scraper, I can change the included angle on the scraper, but a scraper by its sheer nature is a much duller effect. So again, it doesn't really matter. What does matter is if I can now imagine this as being my a bowl gouge. This would be the equivalent of what's happening in a bowl gouge. If you get really, really high angles in a bowl gouge, or low angles in a bowl gouge, that, which is the edge, that'll become more prone to catching. I'll cover that again in a few minutes. I'm going to go back into my PowerPoint presentation. Is anybody still awake?
I'm just listening.
So, you can get a flat grind by two methods. You can either use a Sorby belt co-edge grinder, or you can use the land like this one on these grinders. My comment is you do not use the side of a vitrified wheel. They're designed to take load this way. Putting a load on the side is a huge risk of safety, and they tend to explode if you're not careful. Or even if you are careful, I shouldn't say that. I've seen videos of guys that did that, and they lived, but not very well after that. So just a comment on that. So now the one question was asked is what actually happens. I put this graph together to show what some people are asking. As I take my skew and I change the angle on it, because of the geometry and the way geometry works, the actual angle of the included angle that you're seeing actually drops off. So as you go from straight to more and more curved, the angle goes from, as you go from straight to more and more curved, the angle goes to closer and closer to 0 degrees, the cutting degree. And so if I have a skew that starts off at 60 degrees, it'll end up down at 20 degrees. So as I tend to move my skew around, you think you've got a 60-degree included angle, but you're actually down in this corner, in this region in here, down in the bottom region in there, showing where you're actually cutting. So again, Jim, to your point, does it make a difference? What you're comfortable, guys, is what you got. Don't worry about what everybody else is doing. Make sure your body shape and everything else is comfortable, and make sure. And again, to your point, if you don't have a flat thing, using a wet stone or a stone for final polishing will give you that straight edge, and it only has to be a very small amount, but it's all you need to make it sure it doesn't catch anything. So, if you take a look at the stuff that Sorby said closely, that the actual and use of a skew, that they say that the included angle should change, and this was for hardwood versus softwood. A flat grind is less prone to catching on the wheel, and a skew skew angle changes the included angle for the same grinder setting. But most of all, what you have to worry about is your posture.
Hey, Doug, I
Yeah.
have a question about the first point. They have under a subtitle saying impacting the height of the tool rest. Can you explain that a little bit? I've noticed Turner saying, well, with this tool, I need to raise it up or lower it. What is happening? What's the dynamic there? Is it just the way the bevel's hitting the wood, or what is it?
The answer, can you put that on me again? Let's just take it.
Yep, I guess it.
So, I want to be turning this angle here. If I change the height of if I start changing, if I look at the headrest and the comfortable angle, and that's my tool, I'm riding the bevel. If I change my tool rest down, in order to ride the bevel, what I have to do is actually change the angle of my tool again. So the bevel is really mostly about, or this whole tool rest is mostly about how you're holding the angle of your tool. If I go up to the top more, you'll notice I can actually rest more on my actual bevel itself for making that cut. And for me, I like it up at the top because that way I can make this very straight cut. And I'm running along the edge of the tool rest. I'm making a very straight cut, and you don't push into the wood. You push on your tool rest. So go ahead.
So you're when you say changing the angle, you mean the angle you're approaching the wood at,
Yes.
right?
Yes.
Of the tool. Okay, see, that's another angle to consider. Okay.
Yeah. And so when I'm flat there, I'm coming across, and I'm at this, like people say that I'm at, 10 o'clock, 10:30, 11 o'clock or something like that, as far as the actual, where the cutting is done.
Yeah.
I'm coming across there, I'm actually very smooth, and I'm relying on this tool rest to keep me straight. If I go down here, now I've got that motion this way and vertical to keep that tool straight. So I find that going up to the top angle, where people have recommended, just makes it a little bit easier to control the tool.
But you can achieve the same thing. It's just the ease with which you do it, right?
Exactly. Oh, absolutely.
Okay.
Yeah, but
You're turning it around 11 o'clock?
That's where I do it. That's where I aim for, between 10 and 11. Ernie Conover said that, and I found, it's not my idea in the first place. It's just one of the ones that people have said to.
What if you're not turning a cylinder? What if you're turning a cone shape? Then that would.
If I take a straight cone shape, all you're doing with the cone on a skew is actually taking and rotating this blade a little bit. So the cone shape comes because of the rotation of the blade, and it starts to move in, as opposed to actual changing
You have
the
to
diameter.
lift the handle.
For a straight cone, for a straight shape, you need to lift the handle, or you can do one of two things. You can either lift the handle or move it down a little bit more. If you're looking at really serious curves, going down and around more, and again, it's a matter of handle. And the other part I would like to point out with a skew, if you're using it, when I'm taking a look at this corner here, it's the bottom corner, people talk about using this point of your skew for turning. I'm getting way out in the broccoli as far as the sharpening is concerned. But when it comes down to, you turn on this corner here. Well, if you take a look at this, if I turn on that corner as it's coming around, you can actually see this point moving. Okay? But notice the difference in movement between that part and the top point. This top point moves a much greater radius. So cutting on that bottom edge means that when I turn it, I'm actually rotating into the wood a lot less. And therefore, guess what? It's going to catch a lot less. And what happens with one of these, I'm not quite sure. But this is a rounded, this is, sorry, this is a swept back skew. And I think what happens with a swept back skew is you get a included, thank you very much. I think what happens with a swept back skew is you actually have a different included angle from this point to this point on this thing because you've raised it around as you're going around the corner. So that if you start on the top of a swept back skew and then come back into the bottom, you're actually getting to a sharper and sharper condition. Hypothetical, I have no idea, don't quote me on that idea. So, what it really comes back down to, and this is why I like the idea of jigs and stuff like that, is find your angle and make it reproducible and for you, and make it the best you can for you. As far as the tool you have, if you're satisfied, if you wanted to use an 80 grit wheel to make your skew angle, just remember that it's just going to have that much more graininess on that surface when you make it. You know, it's not going to be as smooth as you might like it. So if you want it really smooth, you just need a sharper, go to a lighter or lower grit wheel, a higher grit wheel, sorry.
So here's another newbie question. So once you have your angle established, like on a skew, why would you even need a mechanical sharpening? Why would you need to go to a wheel again or a belt? Why not just on a plate?
Well, a lot of people don't. And in fact, once you've got it started in the first place, then all you really need to do is take it onto a hone with a plate and a couple strokes and it's done. Yeah, sorry.
And keeping that edge.
Yeah, all you're doing is keeping the edge alive. So a lot of guys will actually say, well, they sharpen on a wheel once in a while, but most of the part, all they do is take a couple strokes this way, and you're done.
Because that's what I've evolved into over
Yeah.
the last 2 years now with using a skew a lot. I haven't taken it to a wheel in over a year, and I just keep using the diamond.
Sure.
And
It's all it needs.
Sharp, razor sharp.
And you're talking, in your case, if you have one of the diamond hones like I have here, it's like a 600 grit.
Right.
So what you actually said then that you prefer to use a 600 grit wheel for sharpening your skews, right?
No, I do have a 600 grit wheel, but I don't really use it anymore.
No.
Because I'm using a 1200 grit diamond plate.
Okay, well in that case you use a 1200 grit wheel for sharpening. But the point of the matter is, what you're talking about is one of the other important parts of this thing. A coarser grit only takes off more steel. It doesn't make it any sharper because what you're talking about with sharp is very, very fine point at the end of it. So the 1000X you can hardly see any difference. So so you end up getting your tools lasting a whole lot longer with a finer grit. If you want a 220, whatever, go ahead. But remember, and this is the other part that was mentioned before. I had my big chisel set with a swept back grind like this because I wanted it, everybody said it was better for catching, but then I discovered the idea of a flat grind on it, and I took the swept back skews all off, I regrinded it straight, every one of them grounded back to straight, because as soon as I put that flat grind, all my catching problem went away. So it's like, why bother? And so, but that's where the 80 grit came in, because I had to make it all straight again. That the 320 grit takes a hell of a long time. So if you want to change the grind on any of your tools, that's when you use it. But if if you're satisfied, there's no need to change it again.
Well, the other thing too, the sharper you keep your tools, the less you're gonna have to sand.
Well, absolutely, and that's another question. How do you know when it's time to sharpen a tool? Well, I think Ron Sheehan used to like to say, why do you sharpen a tool? Because it could be sharper, not because it's not sharp enough. But as soon as you start feeling, a dull tool will catch a lot faster than a sharp tool, as far as I'm concerned. So as soon as you start having problems with your tool, and you're finding yourself being tense or holding on tight too much, it's time to think about whether you actually need to sharpen your tool or not, more than it is whether you're doing anything wrong. So an awful lot of people I talk to or I see, they're sitting there going away, and I take up the tool and it's like dull as a whatever. I think that's one of the problems that young turners beginning turners run into in the first place, because they're afraid of sharpening. They don't want to sharpen too much. Well, the advantage of a jig is you don't need 20 years of hand grinding experience to get it reproducible. And to me, that's been a blessing, because I I was a harness maker when I was a kid, and I had to sharpen up all my own razor blades for cutting leather. It's like 5 years to learn how to make it so it finally worked consistently. And I've got all the cuts on my fingers and nails to show that you cut yourself with a dull tool far faster than you cut yourself with a sharp tool.
And they're uglier cuts.
Yeah, they are, actually. The scars are much more worth talking about. One of the other things that people talk about, have problems with, is the vari jig or whatever for turning. And as you know, when you're sitting in here, everybody's got a different way of talking about it. I can go up here. Oh.
Never mind.
Take your tool, take your depth. Pick the starting point and go. Now, what's the difference between that and that? If I have this out 2.5 versus 1.5 inches, or what's the difference between this angle? What actually makes a difference on?
Well, it's gonna change the angle.
Agreed.
Consistency. It's the whole reason you set it at the same depth.
Again, I agree with 100%, but if I choose a depth, and I decide my depth is going to be 1.5 inches, and somebody else has got a 2 inch or 2.5 inches, what difference does it make in the cutting we're making? And the answer to, like Barry alluded to, how you set up your tool, I don't care. It's how I set up my tool and make it consistent, once reproducible. So these things are really important for reproducibility. There is one small thing that happens on these jigs, which I can show you. As I go from 90 degrees, 0 degrees to 90 degrees on that jig, you can see it turns around. The next slide, again, I need to end the slideshow to show you that if I take a look at this point along here, that's the wing of the tool, and this is the nose of the tool. So the wing and the nose, this wing is, people say, well, a 40-40 grind. That wing is as much controlled by how long you hold the tool on the side as it is by anything else you do. I mean, it can get to a certain degree, and you can get a certain wing, but the angle of the wing is more about how you hold the tool. So I'm going to ask the next question. I've got 4 different grinds, 4 different settings for a vari grind of, I call them A, B, C, and D. One angle is Ellsworth grind. If I go back up here, I take what I've changed. I can change this distance here. I can change that distance there. And those are the only 2 things I can also change this angle here. Those are the 3 things I can change on this tooling. Who cares what differences make? So if I go back and I set these up, I have an angle, horizontal offset, and a tool offset. I got these things, and you can see I've gone from 120 to 145 degrees. I've got over half an inch of difference, and the offset has gone from 2 3/4 inches down to 1.5 inches. When I do the twist on this tool, as I'm going through my 90 degrees, this is every 10 degrees, and that's how the actual total angle of the cutting edge changes. So I've gone from, on that top line, on this top line, I've gone from 70 degrees down to, that's just over 50, just around under 50 degrees to a 70-degree swing of my tool. What do I mean by that? Come back over here. That's 0. If I come around by just 70 degrees, that's how much the tool angle actually changes.
Show that again.
Or stand on the other side.
Sorry, stand on the other side.
Yeah, I got it here.
Oh, I got on that side? All right.
Keep moving. So there's straight, it comes around to 70 degrees. Now obviously with this thing I can go way beyond 90 degrees if I want to. and that moves it down. But the point is that is what I'm measuring. And you'll notice here on the very top is that going from that 90 degrees all the way down to, what I say, 30 degrees or whatever it is down at the end here, I'm actually still almost very close to the point of the tool. So when people say that this is the actual area that you're cut with, that's where the greatest area of your variation in your actual angle is occurring, and then it goes straight down beyond that. So, what difference does it make?
Big difference in the amount of pressure it takes on the tool.
Well, actually what happens, and I'm going to come back to, what actually happens is if you take this is a Ellsworth-shaped grinding tool, and you can see that it goes down so that when you get down very close to the end, it's almost a dead, straight, sharp tool. I mean, it gets really, really sharp if you're not careful. This actual skew is down like 10 or 20 degrees, which is below what you'd use a skew. And so that means when you get around to the edge of an Ellsworth grind, if you're using that wing, you're getting a very sharp skew on that. And guess what? Inside a bowl, that'll do. I don't know. Well, I've heard that it catches. Put it that way.
I can verify it.
I have had some pretty nasty catches with that Ellsworth grind sometimes, but that's because I was getting around to the wing and not on the edge of the tool. If I take this picture here, what I've done is I've taken 4 different notches. This is the extreme notches. So this is the top surface, and that's at a 70 degree. So you can, what I'm trying to show here is that the variation of the actual angle of the chisel changes as you get a tighter and tighter straight on the edge. It becomes a much larger difference. So as you go to the straight skew, and as you'd expect, the change of the angle is much less. So that means that as this comes up here, that becomes more catchy on the edge. So if I keep bringing it way back, it becomes less catchy, but then of course you have a problem because now it's...
The shape of the flute has a lot to do with it too.
Yes.
I mean, like a shallow fluted spindle gouge compared to a parabolic fluted bowl gouge. The parabolic flute is going to be really catchy, right?
I think, John, that the shape of the flute, when you're talking about that, is
At the wings. I'm really thinking about the wings.
I can't answer that completely. All I know is that as this wing, as this grinding distance gets larger and larger, it becomes more and more catchy. Is all I can say. And so the fingernail gouge, when you're on around there, that's where the bottom line is here. This one actually has more of a fingernail grind, so that the difference between the point and the wing is very, very small as you're coming around, which is why I think it makes such a good skew thing. This is just a picture to show you that of those 4 grinds I showed you, which gouge is better. Mox nicks, who cares? In the angles you're using. So to Barry's point, these are again more about, oh shoot, it's not even showing. Oh well. So this, to Barry's point, this is not about making it one versus the other. This is about what you're comfortable with and making it so that you use the minimum amount of tool and sharpen as infrequently as possible. This is the gouge is one tool that I'm not sure that I could do the hand cutting on. So the edges of the curvature on this edge also may be longer, and I suspect that also is what makes it more catchy. So, modification. Let's talk briefly about scrapers. Scrapers are just something that you raise the burr on. And what happens when you're grinding, I don't know the physics behind it because it doesn't make intuitive sense to me that when you're grinding this way, a burr builds up on the front of the edge of the tool. It's like, not sure how it works, but it just seems to work. So it's like the bumblebee. The bumblebee, according to aerodynamics, is not supposed to be able to fly, but the bumblebee doesn't know that, so it keeps on flying. So
That's an old wives' tale.
it's an old wives' tale, yeah. Let bumblebees can fly, you're right, it's an old wives' tale. But the 5-degree angle, it says a flat scraper works best with a burr when it's at 5 degrees. So what I'm trying to say with that is that if I'm holding a scraper straight in and I put a slight tilt on my tool as I'm scraping, that's what works best. So why do I put a 5-degree angle on my scraper, included angle? That way I can put it in straight. And I don't know if you've ever gone around a corner, but going on a bowl straight in versus trying to do it on even 5 degrees is a lot more difficult. So I just find that having that 5-degree angle on the scraper makes it so I can go very flush and very straight around the inside along the axis of the turning. And that also means I can get down in the back, in the corners, in the back of a small vessel or box much easier. So, grinding technique. I guess what I've been trying to say is that, we can all talk all about these angles and everything like that. Guys, folks, choose what you want. But there are some rules we're going to ask you to abide by. First of all, don't push harder. It doesn't work. Let your grinding wheel do the work and let gravity do the work. And you just be gentle with the tools and you'll find that you can get much more consistent. To grind faster, if you want to grind faster, get a coarser wheel. Don't go and try and push harder. Just go up to the next level or coarser grip. Smooth motions. Whenever you're making any of these, whenever I'm using my grinder, if I stop at one point, it automatically makes a flat spot. So making sure you have a smooth motion as you're doing it. And you'll notice that across this end, sometimes you get it going down a little bit. Well, again, pay attention to the shape. But that paying attention to the shape you're grinding of your tool is more about hesitating in the right spot and making sure you're grinding through. So I'm not going to stop here at one spot and just hold it. I'm going to rock a little bit, making sure it's always smoothing back and forth as I'm going along with that tool. So pay attention to the shape of the edge of the tool. In summary, find a shape that's comfortable for you and your stature. Whatever you do in grinding, just make sure your tools are right for your stance. And if somebody else has got a slightly different shape, and you have your elbow up in the air or whatever, and you find yourself doing that, it means you've got something wrong. Your stance is throwing your tool is throwing your stance off. Something within the angle, so know which way you want to move it. And that may require talking to somebody else that's got experience in shape and grinding, but nevertheless, if you're getting a sore shoulder or something like that from the way that you're turning on the lathe, it means your stance is wrong. So we can figure that out together. I can't tell you what your answer is. Jigs are for reproducibility. I can go through and practice on a handheld thing, but you know what? It saves you the price of the jig is going to save you a lot of money in terms of total tool consumption over the years. It's just so useful to have. I think it's a great thing. Your grinder you need a coarse wheel for reshaping your chisel or making a burr. So I think of the 80 grit is when I really use my 80 grit grind on anything. It's actually for the scrapers because the 80 grit seems to raise a better burr than a finer grit does. And I use as fine a grit as I can get away for sharpening because it extends my tool life. So my second tool for my bowl gouge is a 320 grit. I can set that in, put it in, one swipe, and it's resharpened, and that's all it takes. And then diamond honing is always there for touching it up. I guess that's the last.
Then don't you get into if you're using a hone,
yeah.
Again, the practice of keeping you not screwing up your angle when you're your hone after coming off your jig. I find it's a lot easier with the jig, but to try to touch that up with the hone, Sometimes I make it worse because I don't have practice.
One of the things that people don't pay attention to on their bowl gouges is if you take a look at the inside of this flute, it's actually quite rough. So if you're going to hone anything, get yourself a round diamond hone and go in the inside of the flute and make that as flat as you can. Make this mirror on the inside.
Or diamond slip.
Pardon?
Or
Or
a
diamond slip.
slip.
Anything that's a fine diamond, but you've got to make that, hone it on the inside, and you'll find that you'll get a lot better life out of your tool.
Plus,
Sorry?
plus your chips wax it easier.
Yeah. When the chips are down, Jim?
You want a shiny hone or whatever, a shiny shaft. Hey, Doug, I'd like to come back to the question of the severe grits. I mean, not severe, the higher grits. Maybe you guys, some of you guys are like my shop. I have one grinder. I have a CBN on the left side for finishing off my tools, and I forget what it is. It's been so many years. On the other side, I have a stone wheel at like 80 because I know that I'm going to occasionally cut regular steel with it. You know, I grind a bolt or something. But I also know that I can reshape a tool. So doesn't that seem, I guess what my question is does a CBN 80 grit work the same way as a stone one?
The problem with the CBN 80 grit that I can think of, Jim, is that an 80 grit wheel, if you start gumming up your 80 grit wheel, you can redress it very, very easily.
Yep.
And the problem with an 80 grit CBN is if you muck it up, you just wasted $150.
Okay.
So I actually I have a 120 CBN on my grinder at the moment. It's my second one, but again, you have to be very careful not to get it too hot, because otherwise. And so I think that your choice of using a vitrified wheel on one side at 80 grit and CBN on the other side makes a lot of sense. And for new people on the wood turning or tool using or woodworking in general, I would recommend that thing. I would recommend the CBN wheel or the vitrified wheels for coarser grits, regardless, just for that reason, because you can at least recover a vitrified wheel. Of course, you can still break a vitrified wheel if you press it too hard. So don't go trying to do something stupid like that. Yeah.
When you say vitrified, blue versus white, that's a white one there, blue one's back here.
The blue versus white generally is a type of compound they use I think they use for for holding the wheel together. So I'm not sure which is which. So without looking at one versus the other, I can't give you a comment.
I think the blue ones are stronger than the white ones.
Yeah.
And the white ones grind down. They remove, at least if it's what they call them, friable or something like that. FRI. Friable. They will change quickly in size as you use them. So if you want it, like for me, if I rough shape a tool on my coarse side, I don't want that wheel a lot different than the one on my CBN side, because then I'm losing all the gain I've had because the angle changes by the smaller wheel. So I got rid of my white wheel because I liked it, but it was getting smaller. You know, it wasn't holding its own. You know.
Hey,
so.
Jim, do you have a Varigrind Wolverine tool on your CBN wheel?
I do indeed, and I had a interesting learning with it. I have it on both sides, the tracks on both sides, and I kept noticing that when I grind on I call it the stone. Well, I forget what you guys are calling it, but the stone side, and I brought over the CBN, they never matched. And then I started looking, and I realized I had leveled my grinder on its support because it was funny about it being level. And I lifted that one side eighth of an inch above the track, and I I said, well, I don't need a level grinder. I dropped it back and now everything's happy. It was a stupid learning. I mean, it was a learning, but it was kind of stupid. So
Can I make a comment, Jim, on that? Can you put my back on my presentation? This is a mistake people make. This length here, as your wheel diameter gets smaller, you got to change the length of the arm. You can't leave this arm the same for the entire thing. So if your wheel diameter is an inch smaller on a vitrified wheel, you got to move this in half an inch to compensate for it.
that's just a pain. That's a
Well,
pain.
Jim, you got a choice. You can either have a pain or you can have a pain with your tool.
Well,
It's the wrong grind.
Hey, Jim, back to my question on do you use a Varijig, a Wolverine jig? It's because, and it's a yes or no answer, really. It's not a protracted answer. Is there are 4 variables when you have the Wolverine jig. One of them goes away when you use CBN or any other, I don't know of any other constant diameter wheel. But if you're going to use a friable or carborundum kind of wheel, it gets smaller over time. And so all of the things that you had memorized, well, I use a 2-inch projection and I use a certain setting on whatever you call the thing you put the heel of the grinding tool in. You can keep all of those the same, and if the wheel is getting smaller, it's changing each time you use it. So it's important that on a Varijig, number one, whether you use an inch or an inch and a half or 2 or 3-inch projection, always use the same projection. Because if I want to get a 40-degree angle, I can achieve it in 2 ways. I can have more projection and bring this out more, or less projection and bring this in more. Repeatability is the key. So if I use a constant, like on here, a 2-inch projection, that's always. Before I regrind it, I put it in there and I set it at there's a stop back there, 2 inches. And I lock it down there, so it is always a 2-inch projection.
But now you've got to change your bar, right? The bar.
And I never, ever change this.
No, of course not.
Find one that works and lock it in. If you're grinding at 40 degrees, you can replicate 40 with all kinds of settings, but only on the nose. As you go around to the wings, changing this changes changes the grind angle on the wings. And so, just as Ellsworth's original homemade tool uses a 23-degree angle, I pick something about like that, lock it down, and don't ever move it. All I'm doing on it is bowl gouges. I'm not doing anything flat, just bowl gouges. And so, if you use different colored markers on, I have white vinyl tape that I put on my bar here. And once I have reground it and I'm happy with, okay, this is the resultant angle, I put a mark right there, say in red. And I have a little chart that shows 5/8 and 1/2-inch bowl gouge, use the red mark. If I'm doing a fingernail grind, I'm going to be going in more, and I'll have, say, a blue mark on there. If you always go to the mark, and you never change this, and you always use the 2-inch extension, or an inch and a half, or whatever, as long as it's all constant, all the variables have gone away.
Except the wheel
I
diameter.
don't even put my tool down and put the magic marker on the steel to see am I repeating it. I know I'm repeating it. The more you can minimize your variables, the happier you're going to be.
You're right, and the only thing I do different than
wheels,
what
right? But Barry's talking about using a constant diameter CBN wheel, and you're
Right.
asking about a vitrified wheel that changes diameter.
All
Yeah,
bets are
but-
off, Jim.
I'm sorry. What I was going to say, Barry, I agree with you on all that. All I do different than you do is I have cut pieces of PVC pipe for the various angles I'm cutting on my gouges. And so when I always have to slide in my small shop. I can't leave that sliding bar in. I rip my guts out, so I have to take it and put it in when I start a turning session, and I select instead of making marks, I used to mark it with felt tip, but it got moved and removed. So I just now use PVCs. They're marked 40, 60 degrees, spindle gouge or whatever. And I just slip them on and I have the exact repeatable. And I'm the same way with you. That little leg, I never figured out what it does. I put it on the second level and I've kept it there for years. So
Thanks.
Thank you, Doug. Thank you all very much.